Hey class, I'm going to go over some basic Ohm's Law principles right now with you guys and give you 3 basic practice problems, some super easy ones, and we'll just kind of go through them, and this should hopefully give you an idea of what some of your assignments will be like, okay? So just as a reminder, Ohm's Law is the relationship between volts, current, and resistance, okay? So basically the best way to understand, or the way I like to describe it, is it's the idea that 1 volt will push 1 amp through 1 ohm of resistance, okay? So it's a relationship between those 3 values, and as certain things go up, certain things will change. So for example, if we have 1 volt, push 1 amp through 1 ohm, if we change this to having 2 volts, it will push 2 amps through 1 ohm. Or if we leave it as 1 volt and we increase our resistance to 2 ohms, it'll be a ½ an amp will be pushed through that with 1 volt. So there's a relationship between all of them. You will most likely see in most literature from other teachers, textbooks, PowerPoints, online, most people always show Ohm's Law, and this is the way I think I remember it best, as the Ohm's Law triangle. So on the top we have voltage, and then we have amperage and resistance. Remember that, sorry about the bell there. Amperage is represented with an I in all Ohm's Law equations, and that's from the French intensity de current from André Ampère, who created or came up with amperage, and it's always represented as I. It can be a little confusing, but just bear with me on that one. So it's V is over I and R. And the nice thing about this triangle, and the reason why people use it, is it's super easy when we're doing different practice problems for Ohm's Law. You find the 2 values you know, and you cover up the value you don't know, and it will show you the correct equation to calculate for that value you don't know. So let's do a practice problem. The first thing I like to do when I approach practice problems is let's look at what 2 things we do know, okay? So in this equation, we see we have 5 volts in our power source, okay? And we have a 20 ohm resistor, okay? So I don't know if you can see that super well on the camera, but it's 5 volts, 20 ohms. So if we come on over to our Ohm's Law triangle, I know volts and I know resistance. I know V and R. And I'm going to cover up the thing I don't know. So I'm going to cover up the I, and that gives us V divided by R, okay? So in this case, we're trying to find out amperage. So I'm going to write my I for amperage, okay? And it's going to equal V divided by R, okay? So V divided by R is the equation for this one, because we don't know amperage, and we do know volts divided by resistance, and we looked at our triangle. That's the equation we got. Now let's plug in those values. Now we know I equals V, 5, divided by R, 20, okay? So 5 divided by 20, I'm going to quick pull up my calculator to make sure I do this right, because it'd be kind of embarrassing if I made a practice video and did it wrong, okay? And I am going to get, hold on 1 second here, everybody. 5 divided by 20 is going to give us 0.25, okay? So we're going to get I equals 0.25 amps. And honestly, a lot of times when we're doing problems, let's rewrite this in the correct SI unit, the SI prefix. So we're going to get I equals 250 milliamps, okay? In this case, I think pretty much both would be fine in a homework equation, but usually I like to go to the SI unit and not have a decimal in front of the numbers, okay? Let's look at our second equation here. And this one, hard to see on the screen, but we know 9 volts is our value, and our, it says here IT, so that stands for current total or amperage total in the circuit, is 50 milliamps, okay? Now this is going to be a good practice because we have to do some conversion here, okay? So in this case we know voltage and we know amperage, so that means we're trying to figure out what in the world is this resistor value. I can even put a little R next to it with a question mark underneath it, resistance question mark, okay? We don't know. So we're going to cover up the R, and you can hopefully see there without my arm blocking it. That means we're taking voltage divided by amperage, so V divided by R. Okay, so I'll take R, because that's what we're finding, okay? Put my R question mark or whatever there, and we'll say we did our thing. We're going V divided by I, okay? Now we write this one out here. R equals, we know our voltage, that's 9, that one's nice. We have to be careful. If we type in 50 here, 9 divided 50, that's not correct, okay? We have to work in the same unit that we're working in with our volts, or we'd have to convert our volts into the same unit we're working with our milliamps, okay? So in this case, the easier thing to do is take 50 milliamps and convert it to a normal base prefix, okay? So we're going to write down 0.05 amps, because that's what it is. 9 divided by 0.05, okay? Just double check this, 9 divided by 0.05, and we have 180, okay? So our resistance in this case equals 180 ohms, okay? And so honestly, for a lot of our examples here and most of our equations and circuits, we're going to be working with different values and resistors from basically like 100 to 1,000 ohms, okay? That's going to be a pretty standard amount. And we're really, pretty much anytime we have an amperage, it's going to be a milliamp value. We'll rarely in this class work with circuits. I can't think of actually a single example in this class where you will work with a circuit that's pushing over an amp through the circuit. By the time we look at the voltages we're working with and the resistors we're working with, you're going to be seeing milliamps a lot, okay? Okay, our last example here. This one we don't know what our voltage is. We're questioning what's our voltage at the battery. Big question mark there, okay? We do know, it says here, IT, so our amperage total is 100 milliamps, and our resistance is 50 ohms, okay? So we have 100 milliamps and 50 ohms, okay? So in this case, we don't know voltage. We cover up the value we don't know. We don't know voltage, cover it up, and that leaves with I times R. I times R is our value. So we're going to write our equation as we don't know volts, so that's going to equal amperage times resistance, I times R, and then we can plug in our values. V equals, once again, this is milliamps. Let's change that into its normal standard writing, not with the SI prefix, so we're going to get 0.1 times R is 50. 0.1 times 50, it should be 5 volts here by the top of my head. Let's just double check it there. 0.1 times 50, and we get 5 volts. So V equals 5 volts, okay? So, just 3 different ways we can do some basic Ohm's Law equations. Remember, 1 volt will push 1 amp through 1 ohm, and then just remember your Ohm's Law triangle, and that should work for solving really any basic scenario where you know these things. In your practice problems, sometimes, and we'll throw this out here, you'll see some equations written like, I'll erase this middle one here just to show you. It won't be shown in kind of circuit form like we've been drawing normally with like a power source, a resistor, and the path written as a loop. You will sometimes see some problems where it will have kind of a linear drawing or a vertical drawing, where you'll see some problems that will be written with like a plus, a resistor, and then down to a negative, and then it will just have like a VCC, 5 volts, and then if it's like an equation where you're solving for the resistor, you know, maybe it will say this is like a 50 ohm, or if it's solving for questioning what the resistor is, oops, it'll have a little arrow drawing that IT, and then tell you the value of the amperage. Maybe in this case it was, you know, 35 milliamps, okay? So you might see them written this way where it's just a vertical line. It doesn't have the whole circuit drawn like a schematic like you see here in an analog circuit, okay? There you go. That's a basic introduction to Ohm's Law.